Standard 7th, Chapter 3, HCF and LCM. Today we are going to study how to factorize into primes. To write a given number as a product of its prime factors is to factorize it into primes. So let's have a look at an example. There are two methods. Method 1 is vertical arrangement. Now, in this vertical arrangement, I have taken for example number 24. How to factorize it? We have to take into consideration the prime factors. So, the prime number 2. Let's see if 2 can divide 24. We check the test of divisibility. 4 is divisible by 2, so 24 is also divisible by 2, the units place. So 2 ones are 2, 2 twos are 4, so we got 2 12s are 24. Now we have to factorize 12. 2 6 are 12, 2 3s are 6 and 3 1s are 3. So the factors of 24 are 2 into 2 into 2 into 3. So these are the prime factors of 24. This is by vertical arrangement. Now let's see the horizontal arrangement. 24 is equal to, we know 2 into 12. 2 keep as it is. Now 12 is a composite number. So the prime factors cannot be a composite number. So we got to factorize 12 now. 12 is 2 into 6. 2 into 2 into 6 is a second step. Now this is a prime number, so we write as it is. 6 is a composite, so we need to break it into its factors. 2 into 3 is 6. So this way we have found the prime factors for 24. One by vertical arrangement method and the other method is horizontal arrangement. Finally, you have to write the answer as 24 equals to, these are the prime factors, 2 into 2 into 2 into 3. So any one method you can choose, whichever you find easy for you to follow. So let's move on to practice set number 11. The question says, factorize the following numbers into primes. Let's take the first number 32. So by vertical arrangement, we write 32 like this and draw a line so that we can write its factors to its left. So the first prime number that we'll try is 2. Since the number, our question is a even number, so 2 will easily divide this number. So let's start with 2. 2 ones are 2 and whatever is left is 1. 1 and 2, 12. So 2 6 are 12. Okay, you can divide roughly. 32 you can divide by 2 and you will get the answer 16. Now we have to factorize 16. So again 16 is a even number, so it will come in table of 2. Test of divisibility by 2 says if there is 0, 2, 4, 6 or 8 in the units place, you can divide it by 2. 2 8s are 16. Now again 8 can be divided by 2. So 2 4s are 8. 2 2s are 4 and 2 1s are 2. We have got all the prime factors for 32. If you want to follow this by other method, this is vertical method, by horizontal method, then how do you do it? 2 into 16 is 32, we know that. Now keep this 2 as it is and factorize 16. 2 into 8 is 16. Now keep this as it is, factorize the number 8. Here we factorize 16. Now we are factorizing 8. So our step is 2 into 2 into factors of 8 will be 2 fours. Now we have to factorize the number 4. So these we write as it is 2 into 2 into 2 into 4 factors are 2 into 2. So we got all the factors for 32. This is vertical method, horizontal method. So let's write the answer. 32 equals to 2 is multiplied how many times? 5 times. So 2 into 2 into 2 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. These are prime factors. We can't leave the sum here in the midway because 8, 4 will be a composite number. So we have to see that all prime numbers are there as a factor. And that's how we factorize the number into its primes. These are called all primes. Let's take the next question, 57. So I find vertical method is comparatively, we can do it more quickly without any hassle. So we'll follow the vertical method. Now let's see the units place. In the units place we have 7 and 7 is not divisible by 2. So let's try the next prime number which is 3. Test of divisibility by 3 says we have to add the numbers and check if it comes in the table of 3. So 5 plus 7 is 12. Yes, 12 is divisible by 3. That means 57 is also divisible by 3. So I take the number 3 and divide 57. 3 ones are 3. 2 carried over here. 2 and 7, 27. So 3 nines are 27. If you are not getting how we have solved this, you can simply divide 57 by 3 in rough by division method, which you all know. 3 ones are 3, 2 left over, 7 comes down, 3 nines are 27, no remainder. That means 57 is completely divisible by 3. 3 19s are 57. So we wrote here 3 19s are 57. Okay. Now next we have got 19. 19 is a prime number. It is not divisible by any number. So we write 19 ones are 19. So the prime factors of 57 are 3 into 19. So we have got the prime factors for 57 by vertical method. Similarly, by horizontal method, you can find the prime factors for 57. Let's go to question number 3, 23. Now 23 itself is a prime number. So it is not divisible by any other number. So we write 23 ones are 23. So factors of 23 will be only 23. So you can write it as 23 into 1. Let's go to question number 4, 150. Now here we have 0 in the units place. So you know that when it is 0 in the units place, it is completely divisible by 2. Test of divisibility by 2. 2 sevens are 14. 1 is left over. 1 and 0 becomes 10. 2 fives are 10. Now 75 cannot be divided by 2. Let's see if it can be divisible by 3. 7 plus 5 is 12. 12 is coming in the table of 3. Yes. So 3 can divide 75. 3 2s are 6. 1 carry over here. So 1 and 5 15. So 3 5s are 15. 5 plus 2 7. And we know 25 is not coming in table of 3. So test of divisibility by 5 now. Next prime number is 5. 5 5s are 25. 5 1s are 5. And here we have the factors, prime factors of 150. Write down them as your answer. Prime factors of 50 are 2 into 3 into 5 into 5. So next, question number 5, 216. It's an even number and we know that 2 can easily divide 216. 6 is in the units place. So 2 ones are 2. Now 16 we cannot divide together, so because we have to take 1 first. 1 is not divisible by 2, so we put a 0. And now we can take 16. 2 8s are 16. Okay. Next, 2 5s are 10 and 2 4s are 8. 2 2s are 4 and 2 7s are 14. Till now we had 0, 4, 8, 6 divisible by 2. So we divided by 2. But now 7. 7 is not divisible by 2. So I will check divisibility by 3. 7 plus 2 is 9. Yes. So 3 9s are 27. 3 3s are 9 and 3 1s are 3. So the factors for 216 we can write down as 2 multiplied 3 times and 3 also multiplied 3 times. Okay, so this way we have got by vertical method. You can even try horizontal method. If you're getting confused here, 2 into 108, how we got this? You can always do your rough work. 216 you can divide roughly by 2. 2 ones are 2, you'll get 0. 1 comes down, you cannot divide, so you take a 0 by division. And 1 6 comes down, 2 8s are 16. So this is how you can find the answers if you're unable to do it mentally. As you practice, you'll be able to do it. 2 ones are 2, we can't divide 1, so 2 zeros are 0 and 2 8s are 16. Okay. Let's move to question number 6, 208. 208, you can see units place a even number, so it is divisible by 2. So let's write the factors. 2 1s are 2, 2 zeros are 0, 2 4s are 8. Again 4 is divisible by 2, so 2 5s are 10 and 2 2s are 4. This number is also divisible by 2. So 2 2s are 4. 1 comes here. 1 and 2 12. 2 6 are 12. 2 1s are 2. 2 3s are 6. Now we got 13 here. 13 itself is a prime number. So it will not be divided by any other number but itself. 13 1s are 13. So the prime factors for 208 are 2 into 2 into 2 into 2 into 13. So it's quite simple. Once you start practicing, you're going to find it very interesting to solve these sums. Sum number 7. 765 is a number. Now 5 is in the units place, so not divisible by 2. So the next prime number after 2 is 3. Let's try with 3. We will add this and see the divisibility for 3. 7 plus 6 is 13 and 13 plus 5 is 18. So yes, 18 is coming in table of 3. 18 is divisible by 3. So 765 is also divisible by 3. How? You can divide and check, or you can do it mentally here. 3 2s are 6 is closest to 7. 1 left over which will come and join to 6. So 1 and 6 16. 3 5s are 15. Again 1 left over from 16 which will join to 5 and become 15 here. So 3 5s are 15. So we got another number to factorize. Now we have to factorize 255. 5 in units place, not possible by 2. Let's check by 3. 5 plus 5 10, 10 plus 2 12. Yes. So 3. 3 8s are 24, closest to 25. 1 left over which will come before 5. So 1 and 5 15. 3 5s are 15. Now again we got 5 here. Not divisible by 2. Let's check by 3. 8 plus 5 is how much? 13. Not divisible by 3 also. So let's divide it by next prime number is 5. Divisible by 5 because 5 is in units place. And test for divisibility by 5 says it should be 0 or 5 in units place. So 5 1s are 5. 3 comes here. 3 and 5 35. 5 7s are 35. Now 17 is a prime number, not divisible by any other number. So 17 1s are 17. So this way we have got the prime factors for 7 6 5. Now you say if I see 5 in the units place and I start dividing by 5. Yes, you can do it. Somewhere later 3 will come and you can arrange it in a proper way. So 765, the factors are 3 into 3 into 5 into 17. So you can start factorizing with any prime number. You can start with 5 also. Let's take number 8. 8 sum 342. Now this number we see units place is 2. So we know it is divisible by 2. 2 1s are 2. 1 comes here. 1 and 4 14. 2 7s are 14. Okay. And 2 1s are 2. Now we got 171 here. 1 in the units place, it's not divisible by 2. So let's try by 3. 7 plus 1, 8 plus 1, 9. 9, yes, it is divisible by 3. So 3 5s are 15 is closest to 17. 2 comes here, 2 and 1, 21. 3 7s are 21. So now we got 57 here. 5 plus 7 is 12. So again divisible by 3. 3 1s are 3. 2 joins to 7, so 27. And 3 9s are is 27. 19 is a prime number. So it will not be divisible by any other number. 19 1s are 19. And here you have your answers. The prime factors of 342 are 2 into 3 into 3 into 19. So you will write it out. 2 into 3 into 3 into 19 are the prime factors of the number 342. Okay. Question number 9. 377. Okay. Now here you will see that we have 7 in the units place. 7 not divisible by 2. So we will try, if not divisible by 2, the prime number is 2, then we try with 3. So let's try with 3. 7 plus 7, 14. 14 plus 3 is 17. Now 17 is not divisible by 3. So we can't take 2, we can't take 3. Then the next prime number we have to consider is 5. Units place should be 5 or 0. Then only the number will be divisible by 5. So not possible with 5. Let's take next prime number. Yes, 7. Now we will have to check whether 7 can divide 377. 377 divided by 7. 7 5s are 35. 2 remains and 7 comes down. And 27 is not coming in table of 7 anywhere. That means 7 will also not be able to factorize 377. So if 7 is not the prime factor which will factorize this, which is the next number we can consider? The next prime number after 7 is 11. So we will try to factorize by 11. 377 factorized by 11. You have to work out for certain sums. 11 3s is 33. 7 minus 3 4. 7. 47 is not coming in table of 11. So 377 is not possible to be factorized by 11 also. So after 11, which number we have? 13. 13 is the prime number after 11. So let's see by the number 13. Let's divide 377 by 13. Okay, so you should know the table of 13 for this. Okay, so 13 twos are, we know that 13 twos are is 26. Let's subtract. 7 minus 6 is 1. 3 minus 2 is also 1. 117 we got. And for this you should know the tables. Now if you don't remember 13, whether to check now 117 is coming in table of 13 or no. So what you have to do? 3 multiplied by which number gives us 7 in units place? Check in your mind. 3 9s are 27. So 7 comes in units place there. So why not try 13 into 9? 13 into 9. 9 3s are 27. 9 1s are 9. Yes, we got the number. So 13 9s are is 117. That means 13 is the number, prime number, which is going to factorize 377. 13 29s are. So 13 is a prime factor. So certain sums you will have to work out like this. If you know the tables, well and good. So 13, how much are? 13 29s are, we got 377. 13 29s are 377. And then 29 is a prime number, so you can't divide it further. 29 ones are 29. So the factors for 377 are 13 into 29. So we had to work out in the rough for this particular sum. Remember, when you're factorizing, you have to use prime numbers like 2, 3, 5, 7, 11, 13 and so on, 17, 19. Okay, 1 to 20 the prime factors are 2, 3, 5, 7, 11, 13, 17, 19. So if not 2, then you have to try with the further numbers. Let's take the last sum, 559. Okay. Now we have to divide 559. So let's check which number will be able to divide 559 completely without any remainders. So divisibility by 2 says no. Divisibility by 3, 5 plus 5, 10 and 9, 19. 19 doesn't come in table of 3, so no. So not by 2, not by 3. 5, 7, 11, 13, 17, 19, so on are the prime factors. Check by 5. No, not possible because the units place is not 0 or 5. 7, 559. If we divide by 7, then what will we get? We have to work out that accordingly. So let's try here. 559 divided by 7. Okay. Now 7 sevens are 49 is the closest to 55. How much is left over? 6 and 9 comes down. 7's table we don't get 69, so 7 is not a factor for 559. 11. Let's try by 11. 11 5s are 55 and 9 remains. So 11 is not a factor. Now 13. Let's try 559 divided by 13. Okay. So when we divide by 13, let's see, 13 4s is closest to 55, that is 52. 13 4s is 52. Students, you need to know tables well for this. Otherwise, roughly you can form a table and keep like this. 26 into 3 is 39, into 4 is 52. Roughly, you can keep a table ready. So, 5 minus 2 is 3 and 39. We know that 15 threes is 13 threes is 39. We are dividing by 13. So yes, we got the answer that 13 multiplied by 43 gives us 559. So we'll write it down here. 13 is our first prime factor that divides 559 completely. Remainder is 0. So 13 43 is a 559. Now I have to factorize 43. 43 itself is a prime number. It can't be divided further. So you should know which are prime numbers. 43 ones are 43. And in this way, we got all the factors. We write down our answer.